Hello, everyone, and welcome to day number 3 of the Python and AI for Algorithmic Trading online bootcamp. Quite a mouthful, but we have covered already quite a few important topics in this regard. And as I was pointing out a few times, what I try to do is to give you a framework, right? A framework for thinking, a framework for working. What I not try to do is to provide you with off-the-shelf solutions where you can say plug and play, and the trading bot that I offer you starts making money. This would be nice, but usually this is nothing that you get. I know that on YouTube and other platforms you will find a ton of these traders. I'm usually pretty reluctant to believe anything that they say, because if somebody has kind of like the killer trading strategy engine, whatever, right, they usually wouldn't talk about it, right? When they say Renaissance Technologies with the Medallion Fund is one of the most secretive funds out there, institutions out there, right? And this is for a reason, right? They simply don't want to talk about what their secret source is. And therefore, if somebody is talking about what they do, how much money they have made, and then how they did it, right? I'm usually quite skeptical in this regard. But this is not our major topic of today, to judge other people or to talk about my opinion. This is rather about technology. And I promise that we start from frameworks, ideas, and we go to the cloud deployment. And this will be our major focus today, the cloud deployment as a goal, so to say, on the way to the cloud deployment. We need to take a few hurdles, but I think they should be easy enough to take when you, for example, have mastered to set up a demo account for Runda, which shouldn't be that big of an issue. You have, with the guidelines that I provided in the previous session, right? You might then see, meaning by guidelines, I mean when you follow along and open a demo account for UK-based trader, right, where we get the API access, which is called V20. You see here I have my demo account. This is, for example, the client ID that is required for the configuration file, right? And you find up here, let me check, where was it? Trading tools. Under trading tools, you find Wanda API. And when I click on Wanda API, you see here that for me, it says you have generated a personal access token. So I have mine and I want to stick to it for the time being. I could get another one, a new one here by clicking on revoke, but for the first time, you need to create such an access token, right? And then you put it, as we have seen before here, we are not on tpq.io, tpq, not .io, tpq.oa, all right? I want to get started with that because some of you might want to do it right now. And this, I have done this often also in live workshops where people were indeed able to easily follow along. So here you see the structure of this file, and you put the account ID that I pointed you to. Then you put the access token here, and you simply put here practice. Forget about the rest here, right? So that's already it. And the file must have this very structure with the square brackets, Wanda, account ID, everything must be in the way. Of course, you replace here the variable values, right? But everything else should have this structure. You can, for example, copy this here, and then you paste it and override what is to be overwritten. So that's important for me to have this mentioned here at the very beginning, because we will rely on the respective API connection for what we are going to do today, right? I'm just seeing that somebody is saying something about audio. My mic is on, and GoToWebinar shows that the transmission should also work. So if there are persistent issues, maybe let me know. But as far as I can tell, from my end, everything should be working as indicated by the GoToWebinar application. Yeah, that much upfront. As a reminder, I have said this already on day 2. And yeah, there's somebody asking about a CPF program, so I try to, when it makes sense, to answer the questions. During this bootcamp, I won't be able to speak that much about a CPF program, but I can point you to a number of videos, for example, and other resources that provide you with hopefully every relevant detail. But here in the Algo Bootcamp, time does not allow to go through these, yeah, to our comprehensive program. That's simply too much and would eat up all the time. Yeah, so that as the introduction and as the upfront reminder for everything that follows, you need to have a account with Wanda. Here again, once again, the link to the major resources. This is in the gist. So in the meantime, I have done some minor updates. So when you have a look at the gist, this is yeah, not in a major way changed, but I have done some additions and maybe here some corrections, and I didn't push on day 2 everything that we have been going through. So check it out, and as you know, here we go and we'll update things, right? For example, up here, where do we have it? This here can also be updated. Let me do so at this point. Now that I'm pointing you to it, there is yet something else which I've added for today, namely a third Jupyter notebook. The third Jupyter notebook contains stuff, contrary to the previous 2 days, contains already stuff, but this stuff is simply copied from day 2. And I want to use this in a restructured fashion to go and leverage data, for example, that we get from Wanda, that we then pass into the trading algorithm, etc. pp. Right? So this is what we will use. But everybody should have access to all the resources. Everything should be there for everyone. Right? If not, just let me know on the Discord server. Right? So the overview, deployment is the topic. I would assume that the trading platform is now available for everybody who wants to follow along. We have covered with end of day data, AI-based strategies, making use of deep learning, right? And now the deployment. The deployment shall happen in the cloud, and I'm absolutely convinced that this is the only proper way of doing so. I would never come to the idea and, for example, to run a strategy out of a Jupyter notebook on a local machine, right? Oh my goodness, what can happen on local machines? Think of internet connection, think of electricity outages, think of whatever. Or maybe, I know there are many people, let's say younger, being at the university, they might have, let's say, one MacBook, for example, or one Windows laptop, and they need to carry around the laptop. And if you want to do some trading, this simply doesn't work. Neither does it work, I mean, even in a paper trading context, right? If you want to run strategies for a bit longer. Therefore, the cloud, in the sense of a robust, reliable deployment, I think is the only way to go. And it is by far not an expensive way, and it is also, I would say, by far not a much more involved and complicated way, right? If you followed along with the Docker container usage and let's say the install sh script, etc., what I've been demonstrating, what you might have been using as well in the meantime, right? Then there is not that much that comes on top. It's just that we need to have a different piece of hardware, and this is provided by somebody else in some other location, right? That's the major difference, but the behavior is pretty much similar to our usage of the Docker container, right? So I want to jump through this, right? We have discussed AI success stories, check on that part, right? You know, what I think in terms of physics, envy, and finance, and the beauty myth, right? Many models don't conform to reality, and therefore here many prediction fails that can be reported. Sometimes they fail, as we can see here, miserably. Just have a look at this, a major drop, and the prediction was a major rise. I have emphasized this over and over. Here, a paper on the topic, efficient markets is what we are up against. Yeah, we need to take this into account, that this is in the end the enemy, that we let's say, even if we, I don't know, let's make up an example, even if we make 5% consistently year over year, if the S&P 500 makes 12% persistently year over year, then where's the point in it, right? So even without losing money, efficient markets might still kind of like the enemy. We say a passive investment would have saved time, effort, sleep, whatever, right? So we need to keep all of this in the back of our head. We have data, and today this part will be even more pronounced in the practical application, right? We are not required to have a look at any kind of newspaper, right? Nor do we need to read on the web anything, nor on the terminal, if you like. We can if we fancy, but not for our algorithmic trading endeavors usually, right? We use and leverage APIs which give us, in our case, numerical data. So we won't go, for example, on the unstructured data side in the form of natural language processing. This won't be the case for us here in the bootcamp, right? I said, for example, in the CPF program, we have a pretty long and detailed class about natural language processing basics, going starting with the very basics in pure Python, going to transformer architectures and different applications like translation and whatnot, right? So this is something that takes hours on end. We want to focus here on the numbers. AI, so it doesn't matter how beautiful your theory is, it doesn't matter how smart you are, if it doesn't agree with experiment, it's wrong. That's what we need to agree, and therefore we might love financial theories, but we rather do our own experiment, right? We shouldn't be too convinced, let's say, about technical procedures or whatnot. We should really go into it without any preconceived idea and see what the data is giving us. Scientific method, we have discussed at length. Machine learning is the scientific method on steroids. I like this expression, right? It's on steroids. We can repeat stuff over and over again without us getting tired and needing more and more coffee. The machine does the trick for ourselves. We have discussed the changing idea of efficient markets in a modern world as compared to the 50s, 50s as well, but the main ideas were developed during the 60s, the 70s, and so forth, right? Very important stuff for us. And here also we might need to go more complex instead of trying to reduce stuff. What is the highest level in physics? I would say the more simple something is, the better, right? And we see all these wonderful equations around. But for finance, it might be rather than natural language processing, for example, in the form of LLMs, large language models. We need maybe billions and billions of parameters. We need billions and billions of documents and examples to train the model on, and we need maybe a ton of money to get all the models trained. So who knows for sure, but this might be the direction and the trend at least. More and more data and nonlinear, high-dimensional changing relationships, these aspects cry for AI in finance. We have set up the infrastructure. This should be a check. We will now put it from our Docker container to the deployment in the cloud, right? And I think I've uploaded it. Let me just go to the end. Yeah, I didn't refresh it. So let me go to 57 again. This is what I've added before. So day 3 deployment, regular I get asked, and often I do what I call mentoring sessions in the CPF program, where I talk about hardware. And here I can show you hardware that you can find in our office here in the room. It's not exclusive what you see here. There is a bit more, but this is what I'm using. There is, for example, the MacBook Pro still, the M1 still fast, wonderful, great machine. That's the oldest one that I have still in, not really use. I don't use it. It is there, and every once in a while I update it. This is an i7 Mac Mini. This is maybe just 40%, 30% as fast as the 2020 M1 Mac Mini, right? So I just bought it back in the days for testing and experience and being able to talk about it. I thought my 2,500 euro Mac Mini would be much faster, but to the contrary, this 600 euro Mac Mini was much faster, and this was just 2 years old than the more expensive one. So then recently I got that's not Mac Mini, sorry, that's Mac Studio here with the M1 Max chip, 32 gigs of RAM. That's currently the machine I'm working on, right? So that's a pretty decent fast machine, and I got it because it wasn't the newest model on the market. I got it for a steep discount. That's wonderful. But if you would ask me, Eve, if I can only buy one machine, which one would you recommend? Without having tested it, but everything I know about it is the new Mac Mini M4. 16 gigs, 256, you get it for 600 US dollar, or you get it in Europe, in Germany, for example, for 699 because we need to pay VAT on it. This seems to be the best value for the money, right? The M4 single core chip seems to be twice as fast as the M1 single core, right? That I'm working on. So that's of course tremendous, because at least for me, the single core performance is still dominating. Of course, there are tasks where you need maybe 10, 12 cores, or with the Mac Studio maybe a little bit more RAM, right? But the single core performance, this seems to be impressive. And you get 4 Thunderbolt ports, etc. pp. This is, many people have said that this is rather a smaller Mac Studio than a smaller Mac Mini, right? It's closer in terms of performance and what it can do to the Mac Studio, which was of course on another price level when it came out, and still is on another price level. So that I would say for in Germany 700 euros currently without any discount, and 600 in the US. These are the numbers that I'm aware of, right? That's a good deal for money. But, and here is the way out of every misery. Here we go now, and this is our starting point into the cloud story, right? No matter what you have, you can have the fastest machine. You can have the fastest machine, let's say for gaming. My son has a really fast gaming machine because he is in gaming. Now he's studying data science and artificial intelligence, so you might be able to do some real proper stuff from my point of view with the thick NVIDIA graphics card that is in his machine, right? But still, for depending on the application, what you want to do on your use case, going in the cloud, deploying stuff in the cloud might be the only way open or recommended for you for the use case at hand, right? And this is much, much easier than thought. So behind the this link here, and also in the gist, there is a special code. So when you, I don't know if it does it now, when I right click it and open it, you see this is what I wanted to show you. When you follow that link, this is our referral link, right? You don't have no disadvantage by using our referral link. You get here a $200 credit. So when you sign up here, easy affair, pretty easy stuff, right? You get a $200 credit. So even if you say, yeah, I try it for the bootcamp or for the stuff that we do in the bootcamp, but later on, who knows? No issues, right? You have $200 that you can use in order to fire up your cloud instances. And when you afterwards stick to it, and only then, right? Only then, and you might then spending $25 over the course of a number of months or weeks or whatever, then we get 25% in credit. I like it that they openly show it here. So you see, you can save $200, and if you like it, and spend $25, then we get the first $25. If you don't use that link, it works the same. I'm not sure what you would get in terms of free credit, but with our link you get 200. So I'm not affiliated with them. They once approached me and I said, well, that's good enough where we have the referral link. If our CPF delegates, etc., can benefit from it, that's of course a wonderful win-win-win situation. And I'm still, from the pricing point of view, reliability point of view, and technical point of view, I'm still convinced, and this since years, I think 10 plus years, of the DigitalOcean offerings that have become much better over the years. And they recently also added GPU droplets, right? What you just see here. So they are, of course, enhancing their offering to keep up with the rest. So that's about the cloud and the link that I've provided. That's the same here in the gist. There is down here, it's a link to DigitalOcean, which has here the $200 bonus attached to it, right? So you would then just sign up, and once you are logged in, this also shouldn't be that big of a deal. This is a typical sign up, right? And then you get, based on this link on the referral, you get your credits and you can get started easily. And by getting started easily, this is basically the first thing that I want to do now, and the rest of the work today I want to do in the cloud. I don't have to. I mean, it's not that you say, well, I fired up a DigitalOcean droplet, now I'm supposed to work only in the cloud. No. I mean, I just want to illustrate that it's basically the same here. I have from day 2, I still have the Docker-based Jupyter Lab up and running, right? So this is all there, and it can stay there. I have access here to the one local folder that is mounted to the Docker container. But of course, this particular aspect here, this won't be possible with the cloud. So we would need to pull, for example, from the gist, the code into the cloud instance, right? So you see here, I have created a second shell script for the installation, right? There is, so far, there's just one change, because when I played around a little bit with a smaller droplet, let's say this has maybe just 1 gigs of RAM, then I ran into memory issues during the installation of TensorFlow. So as we do these days, right, we figure this out, not via Stack Overflow anymore. Just have a look at the daily usage statistics of Stack Overflow. I at least go for such simple stuff, quote unquote, so quick shots to perplexity.ai, and I asked it what can be the issue here, and said, yeah, the pip installer here, pipx, might use as a temporary folder the in-memory capability, so RAM, to make it precise. And if you don't have enough RAM, this can fail. And the error message was not enough disk space. But this wasn't about the disk space, but about the RAM. So if you decide at a certain point in time that you want to work with a small droplet, for example, to save money, or simply do a deployment which doesn't need that much compute, right? In research or backtesting, I would say you would need more compute, more memory. If you just want to deploy something, then this might be enough. And therefore, I have added this here on a small droplet, execute the following. So this makes the temporary directory a real directory on the SSD and not something in memory. You see, therefore, I like to do these more or less live. I mean, they are live, but also live coding. Bootcamps, you always learn quite a bit for yourself, and this is what makes it, at least to me, so exciting. And maybe for somebody else who sees, well, yeah, okay, I learned this as well now, and wonderful that we can now recall how it is done properly, right? So I have also here a third Jupyter notebook, but again, I want to have this then in the cloud, right? This third Jupyter notebook, 03 Algo Bootcamp, this has just the stuff in a slightly changed order, and I've deleted a few things. So the core is the same. I have changed the order, right? So because I want to replace our end of day data with data from the Oanda API. right? And to this end, maybe let's move on and get started. So when I get to the shell, you see up here, I have marked this now. This is Docker. This is where my Docker instance from day 2 is running. Here is where I want to set up the cloud, and this is macOS. So this is also at this point macOS, but this is the shell that I want to use to log into the cloud. So, but I need something to log into, and this is now the first step. So once you have your account set up with DigitalOcean, you have gotten your $200 credit, right? Then you can get started. You see here under the Python Quants, we have our own stuff, and I use the Tools and Skills project to create stuff that is temporary and for illustration purposes. So upper right-hand corner, you see here droplets, GPU droplets, everything else. A lot of stuff. I'm only interested here in droplet. And it loads now, and let's say we work with Wanda. Wanda is located in the UK, so instead of Frankfurt, obviously would be closest for me as a German. This is some 200 kilometers. London is quite a few kilometers more, right? So I might choose London, but this is now arbitrary. I could even go with Bangalore, Amsterdam, whatever, right? So at this point, yeah, we would need to have a good reason to click around. Usually I would go with Frankfurt, given transmission times, etc. There might also be, just to mention it, some legal issues when you say we as a German, we have maybe customer data from Germans, and then we would need to be really careful to host customer data in New York, let's say, right? But let me go for the sake of illustration here with London, right? Data center London 1. Then we have Ubuntu. Here, the version, I go with the version that it shows me here, the 2410. That's the latest one they support. We could go with others as well, but I stick to Ubuntu, what we have been using before. Now I can choose a size, and you see here premium Intel Basic or premium AMD or regular ones. What else do we have? CPU optimized. There's regular Intel, premium Intel, right? Premium Intel, and you see the more premium we click here, right, the more costly it becomes. Here we have like 8 gigs and 4 fast CPUs. I don't know if we need that. Right, regular ones you see are less than half. Yeah, but here the numbers change as well. This was like yeah, not roughly half, but 2/3 maybe. Just click around and get a feeling for what it is. General purpose regular Intel. You see there are many different sizes, different stuff, memory optimized. When you say my application needs more memory, like 32 gigs, 128 gigs, 192, you will find basically everything. But for us, right here, we can go basic. I say we at this stage, right, go with premium Intel, for example, and then there's just the question, do we need 2 CPUs here, 4? I might go for the sake of illustration here with 4, and there are more, so every once in a while they're at different configurations, right? And these values are all per month, right? $128 per month. That's quite a bit. But if you want to test it, check it out. Here you see this is 20 cents per hour. So I don't need to save, because after our session I will yeah, delete it anyway. So if you go with your 200 US credit, oh my goodness, yeah, you can more or less 1.5 months of such a droplet is already in there, right? So maybe let me go with that big one here. I don't need to, right? But maybe for the TensorFlow stuff, yeah, it might be nice. Let me simply go 20 cents per hour is really not the thing. Enable backup, that's not for us. And here now, this is important. You need to generate, if you haven't done so, a SSH key. When I go here and click on new SSH key, here is the explanation of how to create an SSH key. So this is something that you indeed need to do. You can do with password, I think still, but here simply executing SSH keygen, and then you get your SSH keys, and then you need to paste the SSH key content here and give it a name. So I'm working here on my Mac Studio, right? Here is the Mac Studio. There is the SSH, you see here SSH ED 25551A. There are 4 leading AAAs, and I can show you this, for example, here. That's the public key part, right? And this is stored in sorry, I need to let me get my classes on. This might explain why I'm having trouble here finding the right stuff. SSH, and let me see, what do we have? Yeah, we have here the ID ed, right, dot pub. So that's the public part, and this is exactly what was shown on DigitalOcean here. So with cat catalog, I can display it here on the shell. This is the form of the encryption, and here that's the code, right? But just the public part. I won't show you the private part because, yeah, this is private and you are not supposed to share it with anybody. This is like your password, so to say. But this is, it's not a password, but it's like your password. You will never want to share it, right? But here is like the secret key. No, sorry, there's a secret key. That's a public part, and with the public part, which is stored here, right? This is stored. I have copied this. DigitalOcean can verify that indeed Eve from Mac Studio who is accessing the container. So this is the next hurdle that should be taken. So the rest here, it's all wonderful, but I don't really need it. Here I will name this Algo BC and nothing else, basically. All right, so this will then be called Algo BC. Before I used for Docker Ubuntu, but this is now our deployment environment, so that we also have between Docker and the cloud differentiation. And let me create a droplet. So when I first started working with DigitalOcean many years back, the value proposition was that you get your droplet, your virtual machine fired up. I mean, they also provide dedicated machines, but let's say we have something like this here, standard virtual machine, and it is fired up, means commissioned within 1 minute, right? So that's still, I would say, the value proposition. You see, it takes a bit, maybe it's a little bit longer than a minute, but now it's finished, right? And what we need now, this is now our number here, right? So I need that number, and maybe I can, let me maybe store it here, new file IP, so that I have it ready. Later on, that's not important anymore, right? But here because often I would need to copy it again or use it again and do some other stuff with it, etc. But now that I'm here with my copied IP, right, we can now start thinking of what do we do with it. We have a cloud, we have an IP. Yeah, we want to, as with our Docker container, now get to the point where it says something like root at, not Ubuntu, right here. Oh, I called it also Algo BC. I was now in my head, how shall I say, I was confused because in classes that I was teaching at the beginning of the week in the CPF program, I used Ubuntu throughout, therefore I was referring to Ubuntu, but I used here also Algo BC, right? But this is here in the Docker container, this is all local, and now I can use it. I want to get to the same point without the live part on the cloud instance, right? So this is commissioned, we have the IP, and I now get back to my here to the shell, right? And cloud, it says, right? And I now SSH as root to this instance uniquely identified. This is like an email address. An email address is a unique one, right? IP addresses are also unique addresses, like, let's say, or we know it, a street and a number might not specify exactly which house is meant, right? You might need a postal code, a zip code, and the city or whatever, but here it is indeed unique, and this is around the globe. And I can now log into it and confirm it, because that's the first time I connect it. I connect to the droplet and I'm in. And this only works, once again, if we have this commissioned and have provided, that's important, the appropriate SSH key, the public part of it, right? So that's the prerequisite. Now that we are here, right, I could now do here up, whatever, right? Update, right? I don't want to do it now. I just want to log in. I will log out again. What I'm going to do here is I exit. So this works. My SSH key is recognized, etc. I want now from live, I've shown I have installed Cloud SH. I want to copy this SCP. This is secure copy. Here the install Cloud SH, and I want to copy it to root. And now I root at, sorry, not install cloud. Once again, I need it. I can also copy it from here. And I'm going to copy it to the root folder on the server. So here there's the colon, and then I need to provide the absolute, the complete path, right? So with secure copy, you see this, of course, a pretty small file. This doesn't take that long. It connects, it checks the SSH key, and when everything here doesn't complain, looks all good, and my goal is to have this file on my cloud server, and this works here via SCP. For those who have experience with Linux shell, this I would say standard, right? Others maybe from a CPF program, they have worked on local shells. You use CP to copy stuff around, right? And with SCP, I can copy stuff from a local instance to a remote instance, or from a remote instance to a local instance, right? This allows me to work with other machines that are beyond my office here, for example, where I could walk around and maybe use a USB stick, right? That's not the point. So the login now is repeated. So here we are good to go. It says 2 updates, etc. I have here quite a bit of storage, I have a number of resources. If you maybe not trust DigitalOcean, you can execute htop, the resource manager, and indeed we see 8 cores are available and 16 gigs of RAM, right? So this is what we see here. So it seems to be the case that we have gotten what we have asked for. And in the root folder here, and by root I mean the home folder of root, the administrator, I have this file. And when I have a look at the file, this is what was on my local machine. And now let us execute that stuff here and see how far we get. I hope through it all, right? So that we have afterwards, with our preparational work from day 1 and day 2, now a script that sets up everything that we so far needed, right? Maybe we come to the conclusion that we need something else. Can always add it later on, but here it's now going through here Python installation. Now it is concerned with pipx and the installation of the single packages. Well, we have compiled a list of things, right? This takes then a little bit, but in particular in the cloud, I pointed this out with regard to the Docker containers. I might have been doing this over and over, in particular during the phase where we wanted to collect the single elements in appropriate sequence for our package script, right, for our installation script. But once you have it, and once you have installed all that stuff, let's say in your cloud instance in the droplet, right, then usually you might want to do an update later on, but there's no need to do this over and over again. You see, I'm here installing scikit-learn with the script. Jupyter is installed. Also TensorFlow, and TensorFlow failed when I was doing some tests before with the small droplet. I just fired I don't know, one for $6 per month. This is as cheap as it can get, right, for a cloud instance for a whole month. And this was too small, and that's the reason why I've added the 2 lines, the commented out 2 lines or 3, including the comment, so that you know whenever you see something like this, that, for example, pip x is not able to install TensorFlow, then just uncomment these lines and you should be good to go. TensorFlow for sure, a large package, needs a bit. And as before, our goal is then to set up and run Jupyter Lab. And on Jupyter Lab, as before, we then have access to the terminal, we have access to other stuff, etc. And we would like to run this out of a screen session. I have explained what the advantage of screen is, right? This is, among others, the case that when I log out from the server, that everything that I've started before is still up and running. So this can be accomplished in a different way, but I feel and think that screen is simply a good way of doing it. Others do it as well. So I'm now in a screen session, and let me just check IPython. It starts up, import NumPy SNP as a sanity check. Yeah, this all seems to be there, right? And for Jupyter Lab, our primary work tool, I want to set the password as I've shown before. So I think I mistyped here. So it is now written in a hashed way to Jupyter Server config JSON. And the startup command, well, I can copy it again here. So I can go with port 9999 because we here in the Algo Bootcamp have used 9999, but I could also go with the standard 4x8. Right? This wouldn't make that much of a difference, right? So let me therefore, let me think, do we have it all? Yeah, maybe if something else is required, I can stop it. So now comes the point here. This looks like from a Docker container, but it is not locally accessible. But I use this as a starting point here, right? And now let me get back here, for example, to my IP text file, the little one, and copy the IP. And what is here the local host, right, now needs to be the IP address. And you see, I haven't configured, this is obviously a security issue. I haven't configured here SSL encryption, right? So this is unencrypted. Therefore, be aware of everything that is now done in terms of communication between the local machine, my local machine, and the Jupyter server can be intercepted, because it is, I mean, it can always be intercepted, but it can also be read in plain text form. So when I provide whatever, some major insights that I type in a Jupyter Lab, which might be proprietary information or idea, yeah, be careful with that, right? So it's not an encrypted connection. When I execute it, here you see it says not secure. but nevertheless, it runs, and I can go here and type the password that I've chosen before. I don't need to save this, right? So settings, settings, no, here first the theme, and I can zoom in here a little bit. We don't need that one. The only file that we have here is install cloud. Nothing else is there. So I could now go and copy also my other files from my working folder here for the bootcamp to the cloud server. I could do so, but there is a more elegant way, I would say, more elegant. I can here grab the URL of the gist, right? Of the gist. Here, let me put this right next to my other one. Open the terminal here. So, right, so this is where we are, and I can use git clone, provide the URL, and write it into Algo BC, for example, and it clones now from the gist everything here to the server. So this would be one way that I say, for example, I push something to the gist, and from the gist I get it here to the cloud. Because I have access, I can also use SCP, but if I push something to the gist and you are working with your cloud server, then you can pull it from the cloud server, right? So this looks good so far, right? Maybe we can still increase this a bit. We don't need that many characters on the screen. And now up to the third Jupyter Notebook, Online Bootcamp Day 3. Here we have the imports. It's already a first check whether that stuff is installed. It looks so. TPQA is installed, but have a look at it. I don't have my config file there, so the execution of this part throws an error, right? But I can use here the upload functionality. Oh my goodness, where am I? So here I can go to live and use what is in my live folder to upload it, so that after the uploading, yeah, looks good, we now have access to the Wanda API, right? And if you want to retrieve data, here, this was the example that we've used. This is Euro US dollar data, right? And here we have now the plot of the closing price for the mid values for Euro US dollar. Now let's say that we want to trade, for example, Brent crude oil, right? So here in the trading overview, we have Brent crude oil, upper left hand corner, right? This is on, let me move that around. This is on a 5-minute bar level. Let me put it to a 5-second bar level, and let me increase it. So this is Brent crude oil on a 5-second bar level, right? I can now zoom out, and I have a ton of stuff, but you see this is, since it is 5 seconds, right? It's not that long of a time period here. So when I change to 1 minute, right, the time period gets longer now. Let's say, what do we have here? 1 day, for example. Of course, things change once again, right? But here, 1 minute, and yeah, let me just go with, I don't know. So let me zoom it. So 14th of November, 15th of November, and the 13th. So this is roughly, let's check. It needs to load all the data. So our bootcamp going from the 13th over the 14th to the 15th. So today is Friday, markets are still open, and we see now the whole length here in terms of 5-second bars. This it somehow looks like straight lines, but it is not. So when I zoom in again, right, we see here that these are really bars, but they are just 5 seconds, so therefore pretty short. So I have here Heikenashi. The Heikenashi bars indicate trends much better. You see here there's a trend going down, going up, green, red, going down, red, up, down. Right, and this is the data. You see my uninformed trades from yesterday. They have made a little bit of money. Have a look at this on a margin of 2805. I've made 744. So if we could do this on a daily basis regularly, we would become rich people, right? This is not 1.3. This is like 30 times. The leverage here is 30 times. So the profit here is absolutely underestimating the real profit margin, not the margin, the profit in percentage value. So, but this is just a side gig. This is paper money, and this is all too easy. So this would be for a day trader, let's say, with 2 simple moving averages or whatnot. This would be the situation. Have a look at it. Maybe we zoom out. Here we see it's going up, going down, whatever now the analysis is, right? You might add something like Bollinger Bands, for example, on top of it. Whatever, you might know much better than I do here what typical indicators are, what good combinations are, etc. pp. But we are not concerned with any visual cues, so to say. We are concerned just with the numbers and concerned with discovering patterns in the numbers, right? And therefore, we have our approach here with deep learning. And I want to here go now and do some data retrieval on the 5-second level, right? Data retrieval on the 5-second level for BCO, not BTC, what was confusing before. And we want to go here to 4, 11, 13, 11, and maybe just go 2 days. And instead of daily data, I go with 5-second bars. So data info, let's check. We now have 10,875 data points. All right, let me see. Oh, it's just for 1 day, so let me put this to 15. 15 is then excluded. And this is now 21,705. So we have 20,000 data points for the last 2 days. All right. So our DLS-based trading strategy, let's maybe stick to the same approach, but maybe boil it down to 5 lags. So shorter is better. And while I was, at least implicitly, previously after something that looks good, that has a nice performance, etc., right? Here I'm not. I'm now thinking of the deployment part. And for the deployment and the way I want to implement it, of course, we don't want to wait half an hour until we have enough data in order to create the first signal, right? This is not what we want to do. Therefore, I go with 5 seconds. And if I have 5 lags, this means I need 5 times 5 seconds worth of data, real-time data, so that I can use this approach, right? So therefore, again, not everything that is now driven by the requirement to have R is not defined yet. I need to obviously define R here in this context. It's not driven by the desire of getting good results, rather driven by the practicalities of deployment, right? So data R, we can go here with NP log of data C over data C. And this is what I meant by the reorganization. So the Wanda API part was on day 2 at the very end. Here I put it in front so that we have the data. and can then do the backtesting with the data from OneNote, right? So we have the returns. Yeah, let me here stick to it. This goes through. We have here lag 1, lag 2, lag 3, right? I could, for the sake of simplicity, I could also do here the following. Data is PD data frame of data C. So I pick out just the C column and drop the rest. No requirement to do so, right? But now that I've seen that we have in front so many different things, right? It's a little bit difficult, right? So why do we only get here the zeros? Yeah, here we have the movements, but the movements in and of themselves on a 5-second bar level might be relatively small. Let me just check here. PD data frame and plog. Oh, sorry. Here I forgot. I was confused by the zeros, and rightfully so, because I forgot to shift here. Therefore, there is no change whatsoever. And now we are getting values, although the values are quite small. We would all agree, right? On a 5-second bar level, the returns are probably pretty close to zero. Recall the discussion with regard to end of day values here, the discussion about large returns, right? And if this holds true here, oh, I didn't even show a regular histogram, but if it holds true that most of the return realizations on end of day basis are close to zero, then I think we can be assured that this holds true for the 5-second bars as well, right? Therefore, also normalization, and we have seen that normalization gave us the biggest boost in performance and predictive accuracy, so to say, right? But we have the data now available with the shift included. We can now do a drop NA. So we can now move on and leverage our code from day 2. TensorFlow, here it complains about, yeah, this is usually depending on the processors and what version has been installed, there might be some complaining. So here I get it out of the box. So failed to call internal CUDA error, failed to queue in it. I don't know. Let me see whether the model is there or not. Sometimes what it says here is cryptic at best. I hope that it's not something that is really, and this is here where the proof lies here, and it seems to execute. So it seems to execute, and therefore this is more like a warning, and we can, I think I have it here. I have edited here in that one exactly. This configuration can be used here to suppress all these warnings, right? So, but it seems to be running. We now have, of course, a ton of data, right? Maybe that's a little bit long. Let me just see. Recall we had 2,500 data points. Now we have 20,000. Let me maybe just run it 5 times and set it to verbose so that we see the progress. Yeah, it takes quite a bit for every single run, and maybe I stick to it here. And we can predict quite a bit more data. These are the predicted values. You see here we have this overnight gap. There is trading halt for a certain time, and we have a pretty low accuracy here. Yeah, this is also probably due to the fact that we have a relatively small capacity, just 5 training iterations. So maybe we might decide that we want to go not with 20,000 data points, but just with 5,000 as one example. Again, deployment now is my major concern. Oh, you see, after 10, it has changed already significantly. Here, the numbers haven't changed that much. So let me maybe half it. The halving is easily done when I go with 14 here. So we now have just 1 day. Maybe this also makes sense for 5-second bars, who knows? Recall our time series split discussion. So it's training, it's much faster, obviously. Looks more like what we have been seeing before. And accuracy is slightly above, but we can't hardly tell anything here. Alpha 0.3. So, oh yeah, no, this is like overshooting quite a bit. Here in this context, so we would need to train this probably. Let me put this to batch size 32. Just checking. This does not work. Typical thing here. So this might maybe now take a minute roughly. Let's see if we see some significant changes. But again, even if we stick to the current approach and our numbers are not good, I want to have rather a blueprint here, a blueprint that I can share that you can then use to work with, right? Because as you know, I was never in the business of selling strategies, rather showing how to use technology. But still, I want to have something meaningful, not like 5 training epochs or whatnot. That for sure is not the case. So the vectorized backtesting here will now be in sample. It's the exact same setup from day 2, where we have first, quote unquote, the flawed approach. I wouldn't say maybe flawed, a little bit too hard. So if you are aware of the shortcomings, right, then it's not that big a deal, right? Only if you are not aware of the shortcomings, then usually would say it's flawed. But you can do such an exercise nevertheless in a straightforward manner, right? It's still 50. I thought 50 wouldn't take so long. This is like 10 times 80, and it's still not. So, nevertheless, let's check what we get here. It's not the best thing in the world, but it's tiny bit better. Probably, I said we reduce it with that approach, not only from the training time point of view, but we might further reduce it and get, where do we have the data? Here, after we have done this operation, instead of doing that one, let us use data and maybe just 1,000 points, for example. Like this, right? So let me. So now we have just 1,000 data points, not as many as before. We don't need to wait that long, right? Just 1,000 with everything in there, and we can take it from there. I just had today a call where we are working on a large optimization model, and I said, well, let's start a little bit smaller, right? And the same holds true, I would say, here for algo trading as well. Sometimes you simply need to start a bit smaller, and now with 1,000 data points, this should be quite a bit faster and also probably a bit more accurate, right? So the vectorized backtesting in sample is not our big deal. We can check here also for the trading and everything. Oh, just did one trade, so we probably need to train it a bit more. And everything that we pointed out with regard to transaction costs and the number of trades, of course, is magnified in an exponential manner when you, instead of doing daily trading, if you trade intraday on a 5-second bar level. Therefore, when people approach me and say, Eve, I want to get started in HFT and high frequency trading, is your program appropriate to learn stuff? I say, yeah, what do you mean by high frequency trading? Do you want to do it, or do you want to work for a high frequency trading shop? And they say, no, I want to do high frequency trading. Then I say, you can't do it, right? The high frequency trading business is a multi-million-dollar business on the technology side and a multi-billion-dollar business on the trading side, right? So usually people mean what is called, for example, mid-frequency. And 5 seconds is already mid-frequency, 10 seconds, 30 seconds, 1 minute. Then usually people talk about something like intraday trading, 1 minute bar, 5-minute bars. I would even say for retail traders, given typically the disadvantaged cost structure, so a relatively large bid-ask spread, everything which is below 5 minutes, generally, I would say, is too short, right? So here again, for the sake of illustration and for us to not sit there and wait for 5 hours until something is happening. What was that here going on? Where is that now going? Oh, this only has yeah, now we have something here, which looks kind of like a strategy. And I'm not saying that we wouldn't get something similar looking with 20,000 data points. I'm only saying that the training for us here, real time, doing all together is a little bit too long, right? So 500 trades. So it trades basically every 5 seconds. But for us, it will be good because we will see a lot of good things there. Good thing, by good things I mean trades, right? That we can observe. So lags 7, and now the train test split rolling. Let us do a little bit of testing here as well. We have 1,000 data points, maybe just doing 10 like this, and probably this was already too much. Exception counter when calling sequential code. Probably was the create model. I changed it to 5. There must be some place, there might be some issue with 5 and 7, but I thought this might be. Now it is doing its trick. So this was the first of 10. Oh, 70% accuracy. Doesn't look too bad. If we can always get 70%, but still on the 5-second bar level, probably transaction costs, as I was pointing out a couple of times, would eat up everything else. So, but overall, independent of the accuracy values and backtesting results, this is not our main concern. Once again, deployment is our main concern. We now have something that we might want to work with, right? Lots of work, hours on end, days on end, sometimes weeks, and sleepless nights, and waking up in the morning and getting back to the machine and doing more back testing. But there comes a point where you say, well, now I think that's it, right? That's it, and I want to I want to use it and trade it, right? And this is now the point that I want to go through with you, right? Here I am, and I go to my live folder here. Well, there is no live folder on the Algo BC folder, right, where we have everything. And here we now develop something that I call algotrader.py, DL trader py, right? So I do this here with Vim. You can use whatever editor you like, right? Deployment of TF Keras model, right? So we need to do a couple of things, right? Import tpq.io. We need to import, or from TensorFlow import Keras, right? And the idea is now that I might need much more here, right? The idea is that we open the API connection, tpq.ao, tpq.oa, not AO, OA, with our credentials, Wonder CFG, right? And that we then do some streaming, right? So I just let the other part here run. There are a couple of complaints in between, right? But let us check. Yeah, 50, 60%, 55%, whatever. And since this was running, I started already the other file, right? But here we will go and we'll change our TPQOA module, right? So this will be the, how did I call it? DL trader, right? DL trader. So I call this, I get here a class defined as the trader would be the right way. No, sorry. This is called DL trader, and I inherit from tpq.oa. This is where I inherit from, right? So the pass. So when I inspect API stream data, when I have a look at this, we see here that the stream data class is responsible for getting real-time data and processing it, right? There is the bits are retrieved, asks are retrieved, and it transforms it, etc. Right? And this is the part of the class that does the trick of streaming the data, right? this is something we basically do not need to take care of, in other words, right? Then we have here, let me see the other ones. That's the important one. We need to change the on success method. So streaming data is taken care of, check. So we connect and we define the symbol. I have done a demonstration of that yesterday. Then I can stream data, right? And the on success method here, that is called whenever there is a new bit and ask value. So whenever there is new data sample retrieved, and it does basically the most simple stuff that can happen here. Time, bit, ask, right? So the go API stream. Let's say we go with our BCO USD, right? BCO USD, and say stop at 10, for example. Stream data. It gives us the values that are currently coming in, right? So here data is coming in, right? And it prints it, based on this method, on success. So whenever a new data point is retrieved, it calls on success. And on success defines what is happening with the newly retrieved data, right? So in that sense, when I inherit here, I want to define another on success class here, right? With self time bit and ask, and then print algo bootcamp, let's say, right? So when I define this class, I can now say DLT is here my object. I need to pass wanda config. I need to do these steps, right? And DLT stream data, now getting the same, where is it? Here, the same arguments. And it now, instead of printing time, bit, and ask, it always prints Algo Bootcamp, right? Just a little demonstration of the logic behind this class. In other words, for us, when we want to do some live trading here, we change the on success method, right? And then, yeah, collect the data, derive signals, etc. pp, right? And the question is, how do we do our prediction, right? And prediction can be done based on a saved model, right? We have done the back testing, we have our Keras model, and we want to save it, right? So for example, here, after I've done so, the last back test, let's say, I don't know which one was it, this looks kind of good, 60%. I say model, that's the final one, model save the trader Keras. That's a Keras model, right? So, and this should appear here as well. Here it is, right? When I open it, yeah, that's not properly encoded, so this does not work. But the hope is that Keras TensorFlow can read that model and that we can use it. Basically, what is behind the model? These are weights and the meta information for the architecture of the model, right? But here, instead of just typing print argument, we would go and do the following. Let me develop first a little bit of the logic here, and then we change again back to what I've started here with, right? And you might already have noticed that we might need to change what I do here so that we have our own on success method there, right? The API is the same, but we need to have to change one important thing, right? So what do we do here? For example, let me here define self tick data as PD data frame. I define it just here as a class attribute, right? And then we would, for example, do the following with the data. I would create a temporary data frame, and we would have here the bit and put in bit ask, put in ask, and no mid, where we go with bit plus ask half. All right. The index would be the PD time stamp version of time. All right. So, and here we go. And we would then append self tick data as PD concat. We need to concatenate these days. Self tick data and dr. I can, it's just 2 characters. I can leave it here just for the sake of testing. Let's do print self tick data. So develop step by step, and once we have the tick data together, that's already the first important step. All right, so let me do the trick. Self is not oh yeah, self is not defined here. I don't need to use it that way. You see here we now go, and as we go, every new data point that we retrieve, our tick data set, the data frame increases. That's what we would expect, right? 1, 2, 3, 4 until we have reached the end 10. So we can also set this to 5. That's enough for the demonstration. And the object itself, the LT tick, oh, we have the that's a class attribute. I should rather define it as an instance attribute. Self config file, that's already it. Super init. Man, config file, and then I define it here as an instance attribute so that I can access it easily afterwards. So now the self is the one that I need. This worked here, but you saw there were some other issues. So let me now do it again. Streaming. Now only up until 5. You see the speed is not like a given, right? The arrival times are also random upfront, right? For us, and the values that we get are also random in that sense. So here's tick data, not yet at the 5-second bar value, right? So when we want to get something like this, like the 5-second bars, we would say data self tick data dot resample. I would resample it to 5 seconds, but we need a label right here in order to get the sequence correct, and we would take the last value here. So now let's see if it works. So I'm not sure, I don't recall, for example, whether bid and ask as we get them here are floating point numbers or not, right? So this needs to be checked, because now when we do, I can also look it up there. The last value should not cause any issues. Maybe if we would want to calculate the mean value, which would not be the correct one, this might lead to issues. But here, let me first do the resampling and see if it works. So that's now resampled. You see 2 5-second bars, what we need for our strategy. So data, let me just check info here. Yeah, they are float values. That's nice. So I wasn't sure whether they are floating point values or they are received as strings, for example. So, and here you also see for the resample values, even after my 5 retrieved data samples, I still only got 2 in here, because this is now a time issue and not the number of tick data points that I retrieve. Therefore, just the 2 of them here, right? So just the 2 of them, but that's already our big thing here, because when we now have a model which is able to use, let's say, the mid price and give a prediction, then we can derive signals, right? So this is our goal, signals. We have the data, we have basically a model, and we now need to put all of this together, right? So, and I'm going to implement it here further so that you later have the 2 references. I can always copy this from here over there, right? So meaning I can, of course, here and move it over there. That's the easy part. So this was for the sake of illustration, why we go to the onSuccess method, because that's the one that is called here. And yeah, we have that one. I have saved a model. So let me also load a model here. Self model should be have I imported TF? Oh, TF TF Keras load. Oh, Keras, let me check. Oh, it's such a complex one. The Keras load. Oh. TF Keras load model. I think this is what I have in mind. Let me check whether it works or not. It will immediately complain if it doesn't work. Right, DL trader Keras. So it's not the path. So it's the model. Let me see if it does the trick or not. This does not. Let me check. Load. Where load? No, it's TF Keras load model. Yes. So the saving was the easy part, right? Obviously. I'm just checking, you know, they're like, A, there are multiple ways, and B, there are multiple ways of saving and multiple ways of loading it. So Keras model load model. This is another one. I've previously checked it as well. I hardly ever do that part. Let me see whether this syntax works. This seems to work like a charm now. Keras models Did I wrote this before? I think I forgot models, right? When I did it out of memory, I forgot models, right? So we have that available now. And here we need to change our thinking a little bit, right? Because we now have already our lag. So for us, there is no need, once we have such a data frame, now to go through this lagging procedure, right? We just take the last 7 or 5 values in our case. This is what we need, and then we can create a prediction, right? So let me maybe, to speed up things, go with, let me do it with 3. So just to save a little bit of time. Then if length of self data is greater than, we've worked with 5, right? Lags. Where do we have the lags? I think lags was set to 5. I can go with lags here, lags, but I go with +1, one more. Then we do the following. I print model predict, and I pass in here from self data mid. I pass in ilog lags minus lags. Let's see if this all works. So a lot of thinking, to be honest, for me at least. What print but let me just, this is, we are by far not yet there, but we are closing in, right? And if this works, if this runs through, that's already kind of like a good starting point. Print was never closed, here. It was never closed. I'm pretty sure I need to change the format here. I think I need to, maybe it works already when it needs to be 2-dimensional. That's one issue. So, but let's see, it shouldn't take too long when we run it, because I've set it now to 3 single position. Where are we? I don't know what lags currently is. This was wrong parentheses. Was wondering why it was immediately into the if clause here. This closing parentheses was behind the 1, and there it doesn't belong to. Right. So it's now collecting. You see on the 3-second bar level, but I need to run it, let's say now for 50. Got a lot of output. Still collecting. Index error. Yeah, it's the reshape thing, which always gets me into trouble. I need to add another dimension to it. Values, reshape. Either it's in the one direction or the other. That's a pretty long expression now. Oh, I also forget that one here. This might have been the issue as well before. Let me see whether it now runs through. Sometimes you notice I'm too inclined to do it all interactively and not think it through. I feel like getting feedback from Python sometimes. That's what it's again the prediction part. Let me check how this looks. I should inspect it and what it was talking about, not being too action oriented. Sometimes, like with Nike, just do it, but sometimes we should rather, and this is not self. Yeah, but this doesn't look badly, right? This thing here, this thing, I would say from the outset, this looks shape 5.1. Yeah, Keras models. Somebody was pointing this out. This is where how we got it, right? TF Keras or Keras models, load model. Yeah. Thank you for everybody who's following along and providing helpful insights while I'm struggling some stuff. I'm just checking, you know, other questions. Not too many questions this time around. And finally, with a ton of back and forth, I would rather have inspected it up front, but you know, this is, you recall the quote was one of my favorite quotes, the things that you might think you know for sure, these are the ones that get you in trouble. So here a little bit of checking around and testing and inspecting was like the right way to go. And what we get here is predictions, but we have still one issue, right? And the issue is that the model was trained on normalized data and on returns, and we here have prices and not returns, right? So we need to do a bit of work until this just gives us a zero. But the setup, the procedure in and of itself now works. It loads the model. We know what to pass, but we need to do a bit more work still, right? So having said that, once we have done the resampling here, we do self data and calculate the returns here based on self data, the mid value over self data, yet another mid one, but shifted by 1 day, and we need to put here the parentheses so that we can take the logarithm, and we have here the normalized data used for the training, right? And without going into all the details, because yeah, the way we have done this here, like using the normalization, I mean, there are so many different details, and you can read it, for example, in AI for Finance. We have used just one value for the complete data set to do the normalization, and then we do the train test split. This is usually not how you would do it, because by including the test data into the normalization itself, yeah, this has issues because there can be data leakage. But we cannot address every single aspect here, unfortunately, as much as I would like, but I have my mu values and the standard deviation values, right? And these are the ones that I now need to use here as well, right? So I need a similar approach to that part. So let me just copy this element here. Otherwise, the model doesn't know on which level the data is coming in, and it's kind of like completely irritated, right? So this was just our checking. Here we have now the log returns, and then we can have self data. It's now not fully in line, but I simply use it that way now, right? I simply use it that way now, that I say this is self data with the global variable, right? I would need to load it, or I need to copy it, or whatever. These are now constants in our model with the caveats that I mentioned before. And from the normalized data, I would now take the returns data. I need the normalized returns data because this is how the model was trained. So our mid price was just for testing here and see whether this procedure at all runs through, right? But yeah, as we have seen, it only gave us the 0 predictions, which we probably don't want to have. So, and here you see now we are getting different predictions, right? This is a clear 1. This is a clear, also a clear 1. This is a 0, more or less clear. Now we get proper predictions, right? Looks now much nicer. In order for this to become a long or short position, we need to translate this now into zeros and ones, or minus ones and plus ones, right? So I stop now with the printout here. It doesn't take that long, right? Yeah, for sure, the recordings, regular question, and I fully understand it. People might have other obligations. Recordings are available on the Quant platform shortly after the sessions take place. For the previous 2 days, they are already up there on the Quant platform. So we get the proper predictions now. I mean, proper, numerically proper, right? So we can now say here signal is, and I do it here. Let me get that one. So this is self data ILOG. This is these are the features F in a properly transformed manner, hopefully. Model predict F. This is the prediction, and the signal now would be NP sign of, sorry, that's not correct. NP where P is greater than 0.5, then we set a 1, and otherwise a -1. And we can say print, here we need to get this as a value. For example, print P and signal. So collecting data. You have seen this now a couple of times. First prediction. Why is this all none? It just now starts predicting it correctly. I don't know where issues might arise. So we might need to wait longer for a little bit. I don't know what the problem in the beginning here is, where not a number values might be coming from. But from here we see, yeah, that's the value, that's the prediction. Here we have a small value, that's negative, right? So from that point on, it makes sense, right? And we now need to have something like the idea of a position that I want to introduce, right? Maybe I start with it, self position. In the beginning, we are neutral, right? And we now want to go here through the whole procedure and want to implement the trading logic. What is the trading logic? Yeah, when the signal, sorry, I need to, yeah, if signal, I can start with signal is 1, let's say, and self position is either 0 or -1, right? Then we go long. Print going long, right? So elif signal -1, a short signal, and the position is either neutral or long, the position, right? Then we go short, print going short. Else print position unchanged. So this now introduces the logic based on which we trade. You see, this is now much more explicit than our vectorized backtesting, where we have +1s, -1s, and we relate this to the market return. Here we need to go step by step, bar by bar, right? This is what we need to do. We generate a prediction depending on our position and what the signal is based on the prediction. We go long, we go short, or keep the position unchanged, right? So prediction going short. Oh, it says here for the second time going short. This should be unchanged, basically. Ah, yeah, I have forgotten. I have forgotten something pretty important. The logic works. When I go through it, the logic works, but the printout is not correct. And what is assumed here, of course, when I say I go long, I need to change the position. Without changing the position, this will always stay at 0, right? Self position -1. So that's, of course, a very important element here of what we do, right? So once again, so you see we are closing in, you know, we are not that far from having the strategy deployed. From our cloud server. So prediction going short. I don't know what this non thing is here. We have like, now we have so many nons. Ah, yeah, I know where this is coming from. I know where, yeah, this is with the very short intervals, we can have resampled intervals that are empty, right? And this leads to a problem. So I need to adjust the resampling one, right? Well, let me just show it here. Right, you see here in between we have non-values, and when we pass these 5 non-values or these 5 non-values or the other 5 non-values to it, right, then we have the problem here. So I'm going to change 2 things. I add one more here, one more for the wait period. So lags +1, I go with lags +2 because we are working with returns. And I will do, where is the resampling? The resampling is done up here last, and I go with forward fill here. Right, so that we are not ending up with non-values anymore here in between, but rather, right, have this filled up with previous values. So, and while this is running, well, we can now add to the logic, and here this would be self create order. We want to trade BCO USD, and the number of units I now want to differentiate units is given by 1 minus self position times, let's trade with 50, for example, or just 10, doesn't really matter, right? So why do I use here 1 minus self position? I need to cover here 2 cases, and this is, I think, an elegant way of doing so. When self position is 0, I go long 10 units. When I'm short, then I need to close the short position and buy another 10 units in order to go long, right? And that's the same thing now for the going short story. And this should be called create order. Here, when I'm long, I need to close the long position, and want to go short, I need to sell another 10. So here, let's say I'm short, I need to buy twice the number of units, 20. When I'm long, I need to sell 20. And for the initial trade, I need to yeah, for the initial trade, I need to just buy or sell 10, right? So here, prediction, position going short, position unchanged, prediction, position unchanged, etc. PB, right? So this now looks as it should be, I think so, right? Going long, going short. And you see, I was commenting on this a couple of times. 3-second bars here give us a ton of experience, so to say, and we can check what is going on here, right? We don't need to wait 10 minutes in order for the next trade to take place. And with my forward fill approach, right, I now avoiding the not a number values. For 3 seconds, you see sometimes there is simply no data coming in, and therefore the values are 0, right? So this is what we've got. Maybe we don't go to 50. Let's go maybe, I don't know, 25, for example. I hope that it's enough. And now maybe let me do it with the orders if this is all going okay. Here someone is asking with regard to access to the Discord server. It should be a public Discord server. Oh, what was that? It wasn't enough here. The 25. So I don't know what the issue can be, but the link to the Discord server should work indefinitely, so it's not a time limited one, right? Here we go short and we get the output. Position unchanged, right? Oh, it's nice. Ah, now it goes long. Oh, here we go. It's running. My dear, we see it now trading, and it is indeed running and works like a charm. Of course, this setup here lacks a number of things, right? So we currently haven't implemented automatic closing out of a position, right? We haven't implemented logging. We haven't implemented continuous monitoring, and a few more things. But I was saying we touch upon hopefully everything of real importance in the context of algo trading. So here we have come to a point where this all runs from a Jupyter Notebook context, which is already pretty nice, right? But I promise that we put this into, oh, I haven't shown you here in the trading app, but I do it when we put it into the here is still one open, right? Here it's the one thing I said, there is no closing logic currently here. Oh, that one is right. So 10 short, and I need to close it manually once this has finished. So that's the trade here, the BCO USD trade, right? But we want to move it into a script context. So we have this here. Import here. What it also uses, import tensor flow STF. What else do we use? Import pandas SPD. It's what we need. We don't need matplotlib and whatnot, right? That's not the point. What else do we have? I don't see anything here. NumPy, of course, NumPy. How can I forget NumPy? Import NumPy as NP, right? Keras, right? And so that's that. So, and we put this here. This would have been our standard without our now adjusted class, right? And now we define our main part here. And in this part now, indeed, what do? We first instantiate our DLT trader. So DLT, DL trader, not DLT trader, DL trader, wanda config, right? And then what else have we done? Let's give it a check here, class, DLT trader, right? And then for the start of the trading, we just stream the data and stop it here. So stop it after 50, let's say. We'll stick to it, right? And once we are through this, we can say DLT create order BCO USD, and the units are exactly DLT position, and here times 10. So if it's long, no, if it's long, I need to sell. If it's short, I need to buy, right? So that's it. Print closed out final position. And by final position, I mean the final position will be 0, but what was left after 50 streams is now also closed, hopefully, if this all works. So let me save this. And let me maybe, for the sake of illustration, I could do it. Let me go. Oh, I'm running in a screen session. Let me, in order to avoid potential issues, here open another session, ls, right? Let me start Python DL Trader PY. Python 3, obviously. No module. Oh yeah, we have now the same symlink problem here. Pipx list. So let me see here ls, the symlink stuff that I've done before. Jupyter Lab, bin Python. Right, here we go. Python. So I can change that. lns, and we make it here globally available in or via that folder, right? So this symlink, no, let me copy that one also to the local files, plural. Here, this, of course, is also nice. Also to that one, so that we have the two of them. And here, no, this is my Docker container. And now with the symlink and Python, it's not getting me the right Python in the it's not getting me the right Python to execute it. Let me do one workaround here. I don't know why the symlink here doesn't work. Link root, but it's the correct one, right? Root local bin, this looks correct, but it's still here is referring to the system installed one. On our Ubuntu installation, we haven't had any Python whatsoever here. Before we use pipx, etc., there was already some Python, but in this context, the other packages are not available. So maybe it's anyways, it's a good idea now that I think it through. It's a workaround, but also a good idea to run the DL trader here from IPython, because when the process is finished, I still have access to the objects that have been created. This is not the case on the shell. So you could almost say, and in some context, this is my first instinct, right? That this is anyways better to do so. So we are missing important values that we can define in a fixed manner here. Mu are lag closed. Where do I do the normalization here? Self data. It's kind of strange that this works out of the box here, that these values mu and standard deviation do the trick so nicely. It's kind of like, seems to be somehow. It's interesting to see that. Yeah, interesting. R. The values for R are basically, these are the relevant ones. So let me take them out here and define them up front. These are the values for R. That's the only stuff that interests us, right? The values for R. Everything else for us is irrelevant, right? Here for the standard deviation, it's STD. So I write this, and here we run it again. Lags undefined. Now we discover everything that was used from the Jupyter notebook. This runs already a bit longer after having provided 3 values. I hope that it now will run through, that we have achieved our first real milestone here. The model is not defined. Oh, I have used the wrong reference, actually. The wrong reference. Also here, this worked. That's often the problem with these Jupyter notebook setups, because it can reference basically anything that's available in global and local workspace. So here I do the prediction. The major part I'm not doing here with the loaded model. So I need to call here self model, right? Because model was defined in the global namespace, it simply was picking up the global model and not the one that I have saved and that I have loaded. That's an important part of this whole setup, right? Because here I don't have the context of the Jupyter notebook, and exactly I want to reference in this context now, not model, but the one that I have loaded. Maybe a model on which you have been working for weeks on end, and that's exactly the one that you want to use here, right? So let's see, we are closing in, but we have arrived already at the prediction part. Waiting a bit longer. This is all on the 3-second bar level. Although the model is trained on 5-second bars, we now use it with 3 seconds prediction. Oh, there is another. Oh, another one. Another one. Where is another other one? Oh, I didn't execute the saving. Oh, my fault. This was not a coding fault. This was not pressing the key here. This was exactly this point here, self.model, and you saw there was still :W, and I didn't press the return key, or not fast enough, or not forceful enough. Do we? No, there's just one call to the model, right? That's basically it. And indeed, it has executed now. It's straight. It's sticking to the position here and there, right? Position unchanged, position unchanged. And when we have a look here, you see going short, 10. It is short. Sometimes the display might not be as fast as what we see, but this looks as if it would be going. Yeah. The problem is probably that there was a position already open, and then it's now not going long and short, but rather close out final position. Also, this worked wonderful. Now that we have reached the final position part, here there is no BCO USD. So let me run it again. so that we can follow along what is happening. So previously, I assumed that there was still a BCO USD position open, and when with the open position, I start the trading functionality. Exactly. Now we are 10 long. Then it's not going long and short. Now it's 10 short. You see, now it's changing, right? Here, have a look at 10 long, 10 short. And if it doesn't change it now, in the end, it might close it out, hopefully, or something happens technically in between, who knows, right? It is still, now it has closed out the final position. And this is the S&P 500 position, 10 short, right? So yeah, this seems to work. Major milestone achieved. I was pointing out a couple of things. You could, for example, log all this data, and you could do some real-time monitoring and a few other things, all elements that we cover, for example, in the CPF program, where we have quite a bit more time. The bootcamp, at least as far as I see it, is there to not only scratch on the surface, but to provide like the major things for a certain topic, right? If you would have more time, now would be a good point for you to pick up what we have developed together and to take it and change, for example, a symbol, do backtest on other data, do maybe go longer, like 1 minute bars, and then implement it with 5-second bars first, and then run it for a day, let's say, or a few hours with 1 minute bars, and all these elements, right? Adding logging to it, etc. That is something that you can do. I mean, you have access to the resources, so feel free to not only play around with them, put them to good use, I would say. So let me here, this was the prediction part, to put it to good use so that you might one day be able to open your own algorithmic trading business. Every once in a while, I have people who reach out to me that say, well, Yves, that's really what I want to do. Going out and maybe conquer the world, right? And be one day a famous algorithmic trader. I think it's a pretty exciting field. And there is hardly any other domain, subdomain where you can do the real thing with that little input. And by input, I mean investment in infrastructure, right? You've seen there are droplets, $6, right? With that little investment in your local hardware, Mac Mini M4, which just came out, is a wonderful machine. I would say you can do basically everything with it that is related to this topic. You just need, if you open then real accounts, you need just a 50, 100 down payment or whatnot to get started, right? This is what people put in a slot machine within half an hour, and you can here get started and check check everything. And by everything, I mean the the technology and how it works, right? And what they can do with it, and if we can come up with something where you say, well, this is what I want to deploy, right? So here we have, I just check here with the data, and in particular, I need to, before I forget it, I need to download this here to the proper location, right? I want to download that as well here. The trader, of course, I want to download, right? I think everything else was not changed, but I leave it for the time being. We'll also do a zip and then download it completely. But now I have it down here and can locally update it so that you will have access to it as well. So here, this was my major goal. Now that you see, I do my best to keep you updated with the code and checking now quickly. We should find now the other files. That's the number 3, Algo Bootcamp. Why it is not there? Let me do a reload here to unconfirmed download. What is here with the unconfirmed download? There's something, I don't know why this didn't really work here. There might be some, I don't know, security or rights issues. I will get it down afterwards here for whatever reason. Maybe it was still downloading. Let me check again, for example, the DL Trader Live, why it does not. Insecure. Oh, there was here the insecure download was blocked, right? And Kiara's, this was because it was downloaded from yeah, a not secure location. That was the major issue. So that was that bash update. Here is configuration, the second file, and the day 3, the 2 is that, the day 3, 1. I'm scrolling pretty fast here, the model, and here is the DL Trader in the Jupyter Notebook with the correction here model as well, and the installation scripts, and down there, where is the, yeah, see, it's good that we do it real time here, and I go and need to adjust my update script because it doesn't include the .py files, and I think this is one of the major files that we have come up with, so that by now the Python file should be there as well, and everybody can see it hopefully now, and then we are good to go and wrap up. Where is it? Where is it? It was too fast. Here we have it. Here we have it. Everybody can confirm in the gist. We have now our DL Trader .py with the logic that can run, and when we have the closeout of the position at the end. Yeah, that for me was the primary goal for our 3-day bootcamp. Right, you have access to all the resources, make use of it, and I said it. Let's say 600 plus a little bit for monitor, keyboard, and mouse. Everybody has it anyways. I know it. I'm just saying, let's assume there's somebody out there who has never done something like this. This is one thing that you might need, or a Mac Mini or whatever, or a Mac Air or a MacBook, for example. I recommend, you see, I'm a big Mac fan, absolutely. Then a cloud infrastructure, which starts at $6, maybe 10, $12 per month, and you are in business. And in that sense, if you make the best out of it, please let me know. Let me know about your experiences, and I wish you a happy Python and AI for algorithmic trading. I'm still amazed. We started from scratch. We have installed our Python infrastructure from scratch. We have leveraged data that was on the server. We have leveraged APIs. We have applied TensorFlow, dense neural networks, really the core of today's AI scene, right? And we were able, based on at least the demo account here in this context, to leverage our trained model and to place orders in real time and see how our bot, if you want to call it that way, is able to trade. I hope you will be able to do so as well, and hopefully with a lot of success. In that sense, hopefully I see you sometime soon and maybe another session like this. Take care. Bye-bye.